In terms of checking a piece of material that you've just machined, well, this is fresh out of the mill. It's just a little block I used. Basically I'd made a fly cutter and I wanted to check that it was cutting okay, so without too much care just assembled this in the mill and thrown the cutter through it a few times just to clean up all the surfaces. I'm reasonably happy with the quality of the surface finish. For a single point cutter, it's not too shabby. Deburred it, obviously that's really critical. It's very difficult to get accurate measurements if when you go to actually take the measurement the whole thing's kicked up off the table by a great big burr left by the machining process. So really good practice to get into, just to make sure that it's clean, scrupulously clean, so no dust, no swarf and no oil. Same applies to your surface table, whether it be a tiny little one like I've got here or whether it be a nice great big one like you're using in the workshops. And there is your piece of material, and we can start to take some very basic measurements. So I might just want to drop the accuracy down a little bit, but go for high speed, and we could go in with a vernier and we can just bung that across there, and we can get simple length measurements, width measurements, all quite straightforward, very quick, very easy. Not the most accurate thing in the world. Next up on the stairs of accuracy, we can get our micrometers out. So you have to excuse me, I've only got imperial micrometers, but the more time you use micrometers, more time spent, the more accuracy you get, the better your understanding and feel for the micrometers, and you'll be able to get some good and most importantly repeatable figures. We want to be able to take this measurement, we want to be able to take the micrometer off, we want to then be able to go back, put it back on again and get exactly the same measurement, because if we can do that 2 or 3 times, we have to trust the figures that we've seen on a micrometer. So in terms of length, it's fairly straightforward. We can just use any of the measuring devices that we've got, verniers, micrometers, to get a good understanding of the dimensional length and width, etc. of a piece of material. Squareness, well, squareness is fairly straightforward. Engineer square, line it up, and then what you need behind it is a good light source. If you've got a good light source, you hold it up to the light, and then you have a look along this transition line we've got between the square and the object that you're testing, and if there's any light coming through along this edge, that tells us that it's not perfectly square. So square's very easy, straightforward, quite quick to use, very difficult to quantify by how much it's out of squareness using one of these, but it's more of a yes-no kind of gauge setup, and again quite quick and fairly easy to use, providing your tools are well looked after. Bigger question, I suppose, is how do we tell how parallel this face is to this face, let's say. Don't forget, I've put this in a mill and I've cut the top, and I've then turned it round and cut there, and turn it round and cut there, and turn it round and cut there. There's lots of opportunities for me to have got a bit of swarf, dirt, etc. underneath the material or underneath the parallels as I set it up, that will make this out of true and no longer parallel. How can we measure that? Let's set up. So I'm going to check it with DTI. Got it set up on this stand. Stand's got little pins at the back. They're quite useful because you can just push them down and then that locates on the back edge of my little surface plate. It means it's not going to move backwards and forwards too much, so it'll always give me a quick, easy position. Just rise that up a little bit. Locked off. See, we're a little bit high, so we just want to get that so it's making some contact. There we go. The advantage of using this type is we can, let's get the 0 up the top, we can easily adjust by moving the position of the arm to give us a 0. There we go. So what we're now doing is we're checking the parallelism between this top surface and the surface plate. And if I slide my block along, keeping it in good contact with the surface plate, we can record how parallel this is in reference to the surface plate. And just need to zero that a little bit more. Okay, that's spot on 0 there. And if I slide that across, as you see, I've got no deviation running through the center. But now we can also go forwards and backwards, and here we start to see a different picture. So at this point, and my apologies to those of you too used to the metric system, but this is a very old DTI, we are 4 thou out, side, this is 3 thou higher. So here is lower, here is higher. So this, across this little short piece of material, doing it in a rush, I've got 7/1000ths of an inch difference just across that short 1 inch. It remains parallel, and compare. So at the front there I am 5 thou, just about 5 thou under, 0 point in the middle, and yeah, 3 thou again. So high towards the back edge, although I have to say reasonably parallel. Along the front edge, low, but again reasonably parallel. And actually what you can do is you can use this kind of setup to map your positions, and we could actually start to record plus or minus by the height difference from a determined datum, which at this point I've set up as being roughly somewhere in the middle here where it's reading 0. So from this point we can see that it's higher here and it's much lower here. So it's quite quick and easy to set up to get it zeroed. We can mark it all on with a marker. We can then rotate it round. We can re-lift up on the next side, and then one of the things you can do is find the lowest spot. Wow, 10 thou. Yeah, so let's go for the middle there and we'll zero that. So that's our lowest spot, parallel ish to within 1 thou. Start to bring it forwards towards the camera, and we've got 9 thou easy there, right the way across. So that tells me in terms of this direction it's running pretty parallel, but actually if I turn it around this way you can see it's a long way from being parallel, which to me suggests, if we look at it here, because this is very much higher than this point, it's possible I had just a little piece of dirt underneath one of the parallels or underneath the material when I took that particular cut. And best practice on this would now be to go round and round and round the whole, each of the actual 6 sides that we have on here, and actually write on in pen high and low spots, and then see whether it comes within the specification of the material that you want. And if not, you're going to have to go back and you're going to have to work out how, as it's much higher here than it is here, we're going to need to set this up in the mill with it lifted up a little bit at the back so that we can level the whole thing off. Now when we said before that we can't really measure or quantify the squareness of a block by using our square. It's very true. It is a go no go gauge kind of setup. Here we can actually start to map out a little bit more accurately the condition of the block. So I've taken my stand, I've removed the DTI clock, and I've put a far more accurate verdict gauge setup on here. I've also added this round block. Now this just sits in a V groove that's machined into the front of the stand. Ideally this should be a large diameter ball bearing. I can't lay my hands on one at the moment, so we're just making do with the round piece of bar. Some of these stands actually come with an inbuilt radius bumper that sits on the front, which does exactly the same, and you'll see as I go through the actual measuring process the importance of having that nice round piece that we can work our piece of material up against. So I'll move it round and we'll take a couple of readings and see how the block comes out. So what we're going to do with this is we're going to take our block, and what we're doing is we're measuring each face in reference to the surface plate, and to do that we need to keep it firmly on the surface plate, and then we're going to bring it into contact with our round metal bar and the needle of the stylus. And what we can do is, by whilst keeping it pressed on the surface plate, by rocking it backwards and forwards, we can find that point at which it's at its closest, which means it's nice and square on to the needle, which is about there. And we can zero that in, a little bit out, fraction more, a bit of a fiddle with the camera in the way, but we're roughly at zero there. Now once we've assessed that that position is at zero, I can now check the opposite side, which, if we have a nice square block, should be about the same kind of reading. And bring it in, rotate it round until we find that point at which the needle stops moving, and it's far from perfect, quite a lot of parallax on there, but about 0.06 of a millimeter. So not perfect, it's not, both sides aren't perfectly square to each other, but it's not a million miles off. Let's check the other sides. So rotate it through 90 degrees. Going to bring that back in and make sure we're right up against the block. We are, and that's, interestingly, on here the end of my travel is just over 0.2. Yeah, very close to that, just catching on the block. So you need to make sure you're not going past your travel, so you don't have very much travel on these. And it's roughly there. I'm going to zero that in, and then I can check the other side. So turn it to 180 degrees to catch the other side, bring it into contact with our round block, and then we actually discover something quite interesting, because I'm actually nowhere near touching the stylus. In fact, I have to tilt it up quite a lot in order to get it to make contact. So that instantly tells me that there's a problem with the squareness. We know that these two sides are pretty close, and looking at it with the square doesn't look horrendous. If we bring it now round to the side we've just tried to measure, to get that round a little bit further so you might see. Difficult to make out on the camera, but there is an appreciable gap there, which tells me that these two sides are both well off of square. So here the gap is down the bottom. I'm going to turn it back round. Here the gap is at the top. What we should, on a perfectly square block, expect to see is, no matter which side we bring into contact, you will be very close to getting the same reading, because that will tell me that each of these sides is perfectly perpendicular to the surface plate that we're measuring against. This block is far from it, but it's an interesting way of getting some actual figures laid down into how out of square a piece of material is once it comes off the mill.